Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to talk about nth root inequalities, but what we're going to see actually in these problems is that the quadratic inequalities are oftentimes going to pop up as like necessary for our solution. And so I want to do one of those first, kind of get like used to this idea of inequalities again. So the idea of these quadratic inequalities was basically the way I wanted you to do it was sort of first find the roots, and then from the roots you make a really rough sketch, and then basically you use the picture to solve. And so for this one, right, the quadratic can factor. You can get x minus 8 and x plus 4. And then that means that over here in like a picture, right, I've got roots of negative 4 and positive 8, right? And since it's an open up quadratic, right, it's doing something like that. And we want specifically when is it greater than 0, right? So this is my 0 line, right? And so I got to describe this chunk and this chunk. And so that would just be less than negative 4 or bigger than 8, okay? So those two regions, right, would describe where this quadratic is strictly greater than 0. All right. So nth root inequalities, pretty similar, and they don't always end up being quadratic inequalities. It's just that sometimes that'll pop up. The one kind of frustrating part with these is that you have to remember about the domain. Very easy part to forget, but if you have an even root, that may affect the solution, right? So we have to factor that domain part in order to get the answer to the problem. But this is kind of how in general I think about it. So we can always just start by just solving out the inequality, right? And then we just got to remember this part. This is probably the most important little piece right here. Check the possible domain issues, so only even roots. And then you can use like a number line to check the answer, but we'll talk about that here in a second too. So, so for this one, so just subtract 3, right? And then you get 5, and then square it, 25. And then you can add 10 over and divide by 5. And so it looks like anything less than or equal to 7 would work for this problem, but you would be wrong because you've only thought about the first part. You've got to think about this part right here. So for the domain, make it really big and bold, you just need 5x minus 10 to be greater than, or equal to 0, right? And so 5x needs to be greater than or equal to 10, or x needs to be greater than or equal to 2. And so you need to state the answer that would be specifically less or equal to 7, and also at the same time being bigger than or equal to 2. So this last part here that I'm kind of talking about, this is kind of one way to kind of help you see it. You've got this greater than or equal to 2, and this is kind of how I think about it sometimes. I like do that above the number line actually, and then I've got this less than or equal to 7. So less than or equal to 7 looks like that, we're going to say. And it has to work for both of those, right? Like anything greater than or equal to 2 is just where this thing will even be defined. And then anything less than or equal to 7 is what's going to solve it, right? And so what you basically get is, you know, based on this kind of number line, you can see that anything in here will work. So anything that is bigger than or equal to 2, but then less than or equal to 7 will work. So my solution, you could write it this way. So that is like the final answer, right? Because again, anything bigger than or equal to 2 is going to even just be defined. You're going to see the graph. But then it's only going to be less than, and this thing will only be less than or equal to 8 if you're less than or equal to 7. So that's kind of it. You just got to mix these two parts kind of together. All right. So just want to do another example here. and definitely a little bit trickier than the last one. Then we're going to do one more that's probably, I would say, even trickier than this one. And that'll be it for this video. So same kind of thing as last time. Let's start by just solving out the inequality. So square both sides to get rid of that root. Then this is one that's going to be a quadratic inequality. And so we're going to have to kind of use what we know about solving quadratic inequalities from that first problem to solve this thing. It is pretty nice because it factors. You can get minus 9 plus 1. And so the roots are 9 and negative 1. So if you think about the picture, you got an open up quadratic like that. We want it to be greater than 0, so the solution is going to be like an or. So we want to be bigger than 9 or less than negative 1. Right? So this is possibly the answer, but we have to remember that domain part. Right? We have an even root, so we have to do the whole domain thing. We need x squared minus 8x to be greater than or equal to 0. So take out an x. Right? It's just another quadratic inequality. The roots on this one are 0 and 8, right? So if I graph this one, you got 0, you got 8. We're going through those roots, and we want to be greater than or equal to 0, right? So it's another or, but actually this time it'll be including that root and then going up, and including that root and going up, right? So the solution of this one would be anything less than or equal to 0 or bigger than or equal to 8. And so this also is going to be kind of playing a role in my final answer. And then I just need to kind of mix these two things together. And I don't always do it on a number line, but if you need to do these on a number line to kind of see it, do it. But I'm going to just kind of talk through this one. So we know that the only possible solution is this stuff in blue, right? This is just where the thing's defined. So if we're bigger than 9 and it's defined there, then it's going to be part of the answer, right? And we know that it's defined bigger than or equal to 8. So since 9 is bigger than or equal to 8, this part will be part of my final answer. I definitely have the greater than 9 part, right? And if you look at this, we know that it'll also be part of the solution if you're less than negative 1. And over here, right, we know that anything less than or equal to 0 is part of where you can even see the graph. And so since negative 1 is less than or equal to 0, we know that that also is part of my answer. So this is one where the domain actually doesn't even change the final answer. This is the final answer. The final answer is literally just the solution to the inequality, but don't think that always plays a role. I mean, we just saw one over here where the domain definitely changed it, right? It cut off an infinitely many amount of points, right? There's infinite many points less than or equal to 7, or less than or equal to 2, I should say, right? And so, so you just solve the inequality, check domain, combine those answers, see, you're basically taking the most restrictive thing you can possibly take. All right, I just want to do one more problem. It's kind of a weird answer, so let's just get into it. All right, so for this one, let's just do, I was going to say let's do the domain first, but we'll just do the same way as kind of last time. So get rid of that 6 root, so raise everything to the power of 6, and we would have this left over. And if you do just 3 to the 6, you'll get 729. And then I'm going to square out x plus 2 first. So I'm just going to do x plus 2 squared in here. And if you do that out, you'll get this. And then distribute that negative. And then I'm going to move everything to the right side because I like a positive x squared. And so you would have that. And just for the sake of time, just because I know kind of where this one's going, This does not factorize, so you'd have to do quadratic formula, okay? But if you do that out, you're going to get imaginary roots, okay? And so if there's imaginary roots, right, we know this is a really nice thing when we get quadratic inequalities because we've got some sort of quadratic that's pointing up, not crossing, in the axis, the x-axis that we can see. It's crossing on the imaginary axis. And we wanted to know when is this thing greater than 0. And since it's not crossing, it's never negative, right? So the solution to this quadratic inequality would be all reals, right? So that is like half of the problem. And then for the other part, we need to do the domain, right? So we need negative quantity x plus 2 squared to be greater than or equal to 0. And this is actually really nice because it's already like factored for us, right? We have just a quadratic that's like got a double root at negative 2. And it's negative, so it looks something like this right now, right? And we want to know when is this thing greater than or equal to 0, right? And it's almost never greater than or equal to 0, right? It's always down here in the negatives, but right on the x-axis, right, it's going to be equal to 0. So if you write the answer to that, you would literally just say x equals 2, right? Negative 2. That's the only thing you could ever plug in here and get greater than or equal to 0. It's not greater than, but it's equal to 0, sorry. So then it seems like anything in the reals works and solves this problem, but we know that the domain is only defined for one number. And so basically you just combine those two things, right? And the final answer would just be that number, negative 2, which is kind of weird. But this is a good example of one where the domain really affects the answer, right? We're losing literally an infinite amount of numbers from our answer just because the domain is this one number, which is kind of weird. But yeah, that's one where the final answer would just be negative 2. You can absolutely get those things when you solve these nth root inequalities. The only time you don't need to do this too is if the nth root inequality is odd, right? If a cube root or something like that. But I wanted to do the harder ones, which is why I did 3 where the roots were even.